have to be quite patient. In Tangway Village, Hunan, China, 47 teeth of Homo sapiens dating to 80,000 years ago were found at Fuyan Cave. Wu Liu from the Institute of Vertebrate Paleontology and Paleoanthropology and Professor Maria Martinon Torres published a paper in 2015, along with dental remains of other late Pleistocene megafauna. Fuyan Cave, first discovered in 1984, is a cave complex covering an area of 3,000 meters square, found in the limestone class typical of southern China. In the first 100 centimeters, there are 4 stratigraphic layers found in the cave. The hominin and megafaunal remains were found in the second layer, which consists of 20 to 50 centimeters of brown and yellow and silt and grey fine clay. G'day, my name's Aiden, and today we're looking at Fuyan Cave. To date these fossils, uranium-thorium dating was used, as speleothems were found in the cave at the same stratigraphic context as the fossils. Uranium-thorium dating is used to date calcium carbonate materials, such as speleothems, and it has an upper range limit of 500,000 years. The fossilized teeth are morphologically consistent with Homo sapiens, which first appear 190 to 160,000 years ago. The upper or late Pleistocene ranged from 125,000 to 10,000 years ago. Uranium-thorium dating fits into this range and is consistent with Liu's claims that the fossils date to 80,000 years ago. Uranium-thorium dating works for dating calcium carbonate materials, as uranium is soluble in water and is present in materials formed by water slowly accumulating, such as speleothems or coral. By measuring the half-life of uranium-238, which is 245,000 years, and the half-life of thorium-230, which U-238 decays into, which is 75,000 years, the amount of atoms is compared and counted with other examples. Thorium-230 is, however, radioactive, meaning that every thorium-230 atom that decays, a thorium-230 atom is produced. This continues until U-238 fully decays into stable lead-206. This allows for a consistent form of radiometric dating over 500,000 years. There are, however, discrepancies with UTH dating. If the material goes through environmental stress, such as lack of uranium in the water, it will not show up in the calculations, leading to false data being generated. This is more of a problem with organic materials, such as coral, teeth, and shells, and not closed systems such as speleothems, which are found in caves. By testing multiple examples of the same material on a site, then uranium-thorium dating becomes more accurate. Liu et al. Used uranium-thorium dating to determine the 120 to 80,000 years ago range for the hominin teeth at Fuyan Cave. This, however, caused some paleoanthropologists such as Sun and Kerno et al. To dispute these claims and suggest that the teeth found at Fuyan Cave instead originated from the Holocene. By using AMS-14C, or accelerator mass spectrometry dating, which detects the carbon-14 atoms in the fossilized teeth, as the carbon-14 decays over time into stable nitrogen atoms, AMS-14C works through accelerating the ions to an extremely high speed in cyclotron, then observing the amount of carbon-14 and carbon-13 atoms present, determining the age. Sun et al. Found that several teeth dated to 15,290 to 2,370 years before present, which, with a 68.2% probability. They simultaneously used UTH dating on 3 flowstone samples found surrounding the teeth, dating it to 142,000 years ago, 95,000 years ago, and 169,000 years ago. They attribute the various range of dates to small-scale erosional events, sediment collapse, bioturbation, or anthropogenic disturbance during the Holocene. The issue with using AMS carbon-14 dating is that it can be easily contaminated by exposure to carbon-14 in the atmosphere, and accumulation of carbonate over time. Martinon Torres et al. Assessed that the quality of these claims, questioning the validity of the paper. They claimed that Sun et al. Did not provide the precise information or evidence that the teeth were collected from the site, questioning the taphonomic relationship between the teeth that were visually presented in the paper. They also argue that the post-deposited carbonate found on the teeth could skew the data extracted from the AMS carbon-14 testing, as it is difficult to dissolve in an acid-alkali acid method. Martino Torres et al. Argued that the teeth presented are not hominin teeth, but instead are typical of some herbivores. Example, deer. Typically of the Cervus genus. In response, Kerner justified that the contamination of the AMS carbon-14 dating was at no consequence, as it would have only skewed the data to a negligible degree. However, the data that they present pertaining to the morphology of the teeth is not entirely clear. As seen in column B, the tooth of a human from Feoman Hong tomb is significantly different from the tooth shown in column A. Instead, it is visually akin to a tooth from column C, the tooth from the deer genus. The significance of these comparisons calls into question the initial argument made by Zhu Fengshun in that the teeth from Fuyan Cave are only from the last 15,000 years. Another interesting side note is that the teeth of the Cervus genus have also been found at Fuyan Cave, which could possibly lead to further contamination. The teeth discovered at Fuyan Cave highlight an overarching argument: the dissemination of humans across the world. To tackle this, there are two main theories: the out-of-Africa theory and the multi-regional model. The multi-regional model supposes that across the world, hominins independently evolved into Homo sapien populations from pre-existing Homo neanderthalensis and Homo erectus populations, with traits from these archaic populations still found in modern humans being a result of their evolutionary origins. This theory, however, does not account for the mitochondrial DNA evidence present in both ancient and modern humans, showing that Homo sapien populations from 62,000 years ago from Australia, more specifically Lake Mungo, were anatomically modern humans rather than descendants from either archaic Homo sapiens or Homo erectus, and that haplogroups L0, L1, and L5 have the most genetic diversity, which indicates that these populations are the base origin for the modern mtDNA global populations. The mtDNA origins of modern humans strengthens the out-of-Africa theory for human dissemination. Anatomically modern human populations must have moved out of Africa at a minimum of 62,000 years ago, and with the fossil evidence from Fuyan Cave, could have been in southern China by 80,000 years ago. Kaka suggests that during a period of dry humidity in which C3 plants became much more abundant 70,000 years ago, led to migration and spread of Upper Pleistocene humans across southern Asia. This is backed by weaker monsoon cycles that were present from 139 to 70,000 years ago, found by looking at pollen deposits in coastal oceans. It can also be ascertained that anatomically modern humans had travelled along the southern dispersal route before 65,000 years ago. Thus, there is valid assumption to be made that anatomically modern Homo sapiens made up 47 teeth found at Fuyan Cave, being present in southern China 120 to 80,000 years ago. This, however, does not mean that these humans are genetic descendants of modern East Asian populations, but instead an example of the multiple waves of human migration out of Africa. The real argument in the findings at Fuyan Cave is whether anatomically modern humans moved out of Africa before present-day genetic lineages were assembled. Thank you. I hope you had a good day.